right, so today we're going to be working on Chapter 5, Lesson 6, and we're going to be talking about parallel and perpendicular lines. So what we're going to learn is we're going to learn how to write an equation of a line that passes through a given point when a parallel line is given. We're going to learn how to write an equation of a line that passes through a given point when a perpendicular line is given. So some vocabulary to keep in mind are what are parallel lines and what are perpendicular lines. So how can you determine whether two lines are parallel? So the graphing calculator screen off to the right here shows a family of linear graphs whose slope is 1. Notice the lines do not appear to intersect. So here I have y equals x plus 3, right? That's in slope-intercept form. Slope of 1, y-intercept of 3. Here's y equals x right here, which has a slope of 1 with a y-intercept of 0. Here I have another equation, y equals x minus 3, again, a slope of 1 and a y-intercept of negative 3. So if you notice, all three of these lines have the exact same slope, which means they have the same steepness, right? They rise and run at the same angle, right? But you notice here that they do not intersect. They never touch. And even though they both go off, or all three of them go off to infinity, right? They go off in forever in both directions. Doesn't matter. They're never going to cross because they're going at the exact same angle, right? They're kind of like railroad tracks. So parallel lines are lines that are in the same plane that do not intersect, and those are referred to as parallel lines, right? Parallel lines always have the same slope. So here's an illustration here. Two non-vertical lines are parallel if they have the same slope. All vertical lines are parallel, right? So here we go. I have two vertical lines, right? Those are always parallel. And then any other line that's not vertical, right, is also parallel if it has the same slope, right? Because anything that's not vertical is going to have some sort of slope. So as long as they have the same slope, they're parallel. And vertical lines, if you remember, have an undefined slope. So obviously two undefined slopes would be the same slope, which would also mean they're parallel. So you can write the equation of a line parallel to a given line if you know a point on the line and an equation of the given line. So what does that mean? Well, let's look at an example. So in this example, we're going to be given a parallel line and a given point. So here it says, write the slope-intercept form, right, y equals mx plus b, of an equation for the line that passes through the point -1, -2, and is parallel to the graph of y equals -3x minus 2, right? So remember, this equation here represents a line. So we're writing the equation of a line parallel to this one, and it goes through this point. So let's look at some steps here. So the parallel line to y equals -3x minus 2 is going to obviously have the same slope if it's going to be parallel. Well, this is already in slope-intercept form, so I can tell that this line has a slope of -3. So if mine is parallel to that, it will also have a slope of -3. So I already know my m value, my slope has to be -3 because it's going to be parallel to this one. So now I know that I have a point, -1, -2, and a slope, -3. So I can use my point-slope form, or I can use slope-intercept form. In this one, since I have a slope and a point, I'll use point-slope form, and then I'll just convert it to slope-intercept form. So again, I'm going to put in my y-coordinate and my x-coordinate, right, for my point that I'm given. And my m, my slope, I'm going to get from the parallel slope, -3. So I put in my values, and then I simplify, right? A negative and negative, right? Minus a negative is a positive, so that's going to be y plus 2, x minus -1, again, that's going to become x plus 1. And then I can go ahead and continue on here. I'm going to use the distributive property. So -3x minus 3, right? -3 times x, -3 times 1. And then I'm going to go ahead, in order to finish getting it in slope-intercept form, right? Y equals mx plus b. I got to get the y by itself. So I'm going to get rid of this 2 here. I'm going to subtract 2 from both sides. And that gives me y equals -3x minus 5, right? -3 minus 2 makes -5. So now I have my equation, y equals -3x minus 5. This is the equation of the line in slope-intercept form that goes through the point of -1, -2, and is going to be parallel to this one, right? And we know it's parallel because it has the same slope, and obviously they have two different y-intercepts, but that's okay. That means they're just going to go in the same direction, but they're going to be in two different locations. So we can also check this, right? So if we took this equation and graphed it, it would look something like this, right? It would go through here and it would go down through here, right? It's got a y-intercept of -5, a slope of -3, and I can tell it has a slope of -3 because it was down 3 over 1. And here's the other equation, y equals -3x minus 2 that I was given, and I can see that they're both parallel to each other, so it ends up working out. Now let's talk about perpendicular lines. So we know that parallel lines have the same slope, so let's talk about what perpendicular means. Lines that intersect at a right angle, which means 90 degrees, so two lines that cross perfectly at 90 degrees, are called perpendicular lines. This is a relationship between there is a relationship between the slopes of those perpendicular lines. Now they're not the same, but they are related. So let's look. So these would be examples of perpendicular lines. So these two blue lines are perpendicular, and these two red lines are perpendicular, right? A vertical line would be perpendicular to a horizontal line. And so how do I know what the slope is? How do I connect them? Well, if I look at these two blue lines, this blue line has a slope of -1/2, and this blue line has a slope of +2, right? And so the easiest way to remember how perpendicular lines relate to each other is that their slopes are what are known as opposite reciprocals, right? Here it says right here, opposite reciprocals. Opposite refers to the sign, right? So if one's negative, then the perpendicular one's going to be positive. And reciprocals would be if like if you think about a fraction, the fraction is flipped upside down. Okay, that's what it would look if the fraction were to be flipped upside down. So now let's look at the next part here. Oh, sorry. The other thing was, and you also know that if they're perpendicular, if you were to multiply their two slopes together and you get a product, right, an answer of -1. So if I did 2 times -1/2, that gives me an answer of -1. But let's look at some examples to kind of dive a little deeper. Example 2 says, determine whether lines are perpendicular. So here is an outline of a kite, and it's shown by making all these different lines between these points. And basically it's saying determine whether the line from A to C, right, this line right here, is perpendicular to line BD. So to line from B to D. So basically I'm looking at this line, and it's asking me, are they perpendicular? Well, to me, they look perpendicular, but really I have to test and prove mathematically that they're perpendicular. So really what I want to do is I want to find the slope of this line, and I want to find the slope of this line. And you know how to find slopes based off points, so we're going to do that. So let's find the slope of each line segment there. So the slope of A to C, so the slope from this point to this point, right? I have my x and y coordinates. I'm just going to go ahead and use my slope formula, right? Subtract the y's from each other over subtracting the x's from each other. I know 5 minus 1 is 4, and 5 minus 7 is -2. So that's going to give me a slope of -2, right? Because 4 over -2 is just -2. And so now I know this has a slope of -2. So I'm going to find the slope of BD there. So I have my 2 points, my x and y coordinates. I'm going to use the slope formula, so subtract the y values over subtracting the x values, and that's going to give me 1/2, right? Because 4 minus 0 is 4, 8 minus 0 is 8, and 4 over 8 just reduces into 1 over 2, or 1/2. So the line segments are perpendicular because if you notice, their slopes are opposite and reciprocal, right? One's negative and one's positive, and 2 is like 2 over 1, right? And if you do the reciprocal of 2 over 1, that's 1 over 2, right? So these are opposite reciprocals of each other. And if I multiply them together, if I do 1/2 times -2, that equals -1. That's how you can always tell if something's perpendicular to each other, is if you multiply them and get an answer of -1. But let's look at writing equations of perpendicular lines if you know a point and a line. So here it asks us to write the slope-intercept form, right? Y equals mx plus b for an equation of a line that passes through the point -3, -2 and is perpendicular to the graph of x plus 4y equals 12. So here they don't give us the line in slope-intercept form. They give us the line in standard form. So how are we going to find the slope of this line? Well, we're going to find the slope of the line by converting it into slope-intercept form, right? Get it into that y equals mx plus b form, because then we can read the slope. So I'm going to take the original equation here and I'm going to solve it for y. I'm going to put it in slope-intercept form. So I'm going to start by subtracting x from each side, which gives me 4y equals negative 1x plus 12. So this minus 1x, I just wrote it in front just to kind of make it look like a very similar form, right? Y equals mx plus b form. And then I just have to divide both sides by 4 because I got to get the y by itself. So divide everything by 4. So that's going to give me y equals negative 1 divided by 4 is negative 1/4. 12 divided by 4 is 3. So here I have my slope-intercept form. So now it's very easy to see that this equation written in slope-intercept form is this one. So now I can tell that my slope for that line is negative 1/4. Okay, so if I know the slope is negative 1/4, then the perpendicular line is the opposite and reciprocal. So if this is a negative, then my perpendicular slope is going to be positive. And the reciprocal of 1/4 is 4/1, right? Just flip the numerator and denominator, right? The top number and the bottom number get flipped. So my slope is going to be positive 4. Positive 4 would be the perpendicular slope to negative 1/4. So now I know my slope. So now I can use point slope form to find the equation because I have a slope and I have a point. So here's my point slope form. Substitute in my x and y values for my point, and my m is my slope. And then I can go ahead and simplify, right? Minus negative 2 is like y plus 2. X minus negative 3 is like x plus 3. And then I can use a distributive property, right? 4 times x, 4 times 3. So I get y plus 2 equals 4x plus 12. And then the last part is just getting the y value by itself. Subtract 2 from each side. And I get y equals 4x plus 10 because 12 minus 2 is 10. So this would be my slope-intercept form of that line, right? Y equals 4x plus 10. This is the slope-intercept form of the line that is going to be perpendicular to this one, right? Because it's got opposite reciprocal slope. And it's going to go through this point. One last one. So in this example, again, they want me to write the equation or the answer in slope-intercept form for a line perpendicular to the graph of y equals negative 1/3 x plus 2 and passing through the x-intercept. So in this scenario, again, they give me the equation in slope-intercept form so I can tell that this slope of this line is negative 1/3, which I need the perpendicular slope for. And they're telling me that it has to go through the x-intercept. So I have to find what the x-intercept is going to be. But if you remember, x-intercept is just where the line crosses the x-axis. So remember, the line always crosses the x-axis when the y-coordinate is 0. So I have to solve for that. So step 1 is I need to find the slope of the perpendicular line for this one, right? So perpendicular to negative 1/3 would be positive 3/1. And positive 3/1 is just 3. So my perpendicular slope to negative 1/3 is positive 3. And I can verify that if I do negative 1/3 times 3, that equals negative 1, right? Two perpendicular slopes always, when you multiply them, their product is always negative 1. So now I know my slope is 3, right? Positive 3. So if I have a slope, I'm going to go ahead and find the or the x-intercept for that line. So all I would need to do is I can use the original equation, right? And I can go ahead and put in the x-intercept of the line, right? So I have to find the x-intercept for this line. So I'm putting y in. I'm going to put 0 in for y, and then I'm going to solve for x. So obviously that's 0. Subtract 2 from each side, and so I have negative 2 equals negative 1/3 x. So if I'm trying to solve for x, I got to get rid of this fraction. And remember, I can multiply by the reciprocal. I can multiply by negative 3/1, or just multiply by negative 3. And when I do that to both sides, that equals x equals 6. So now I know that my x-intercept has to occur when the x value is 6, which would be the point 6, 0. That's where the x-intercept is for this line. Now, the last part is now I know that I have a point, my x-intercept point, and I have my slope. So I'm going to take this slope and this point and solve for the equation. So I'm going to substitute the slope in and the x and y coordinate into my point slope form. So again, I know that my y coordinate is going to be 0, my x coordinate is going to be 6, and my slope is going to be 3. And then I can go ahead and simplify. I know y minus 0 is just y, and then I can use the distributive property, which is 3x minus 18, right? 3 times x is 3x, 3 times 6 is 18. And so that would give me my slope-intercept form equation, right? My line would have a slope of positive 3 with a y-intercept of negative 18. All right, thank you guys for watching, and let me know if you guys have any questions.